So in this video, what I'm going to do is I'm going to explain the history of how we came up with the atomic theory that we currently have. And so the very first person who we need to talk about is Dalton. Now, Dalton had 4 different postulates in his atomic theory. The first one, and these are going to seem really obvious to you, but what you need to keep in mind is Dalton had no technology available to him in order to discover this. And so what he did instead was completed experiments in order to determine these 4 principles. The first one is that each element is composed of extremely small particles, and he called those particles atoms. So you have an atom of the element nitrogen, you have an atom of the element oxygen. The next thing he stated was that all atoms of a given element are identical, but the atoms of one element are different from the atoms of another one. So oxygen atoms are different from nitrogen atoms, but all oxygen atoms are the same. And we'll look at the characteristics, specifically the subatomic particles, in order to prove that. The next thing he stated was that atoms of one element cannot be changed into atoms of a different element by a chemical reaction. So atoms aren't going to be created or destroyed, rather we're going to have a rearranging of those atoms. And finally, he stated that compounds are formed when atoms of more than one element combine together. So for example, if you take nitrogen and oxygen and combine them together, you will get NO. And that compound, for example, nitrogen monoxide, is going to always have the same relative number and kind of atoms. So nitrogen monoxide will always have 1 nitrogen and 1 oxygen. So a lot of this is pretty, we've accepted this. We don't even consider that they didn't, at some point, scientists didn't know this. Now, what we're going to talk about now is going beyond the atom and actually realizing that the atom is divisible. And specifically, the first person we need to talk about is Thomson. Now, what Thomson did was he took a cathode ray tube, and the cathode rays that are produced in this tube are radiation that originate from a negative electrode, and they travel to the positive electrode. Now, those negatively charged particles are what Thomson called electrons. So those electrons are moving through that electrode tube, and what he noticed was that if he exposed that cathode ray tube to a magnet, then the rays would be deflected by the magnet, proving that those particles that are moving through the cathode ray, that they're charged, and specifically that they are negatively charged. So the cathode ray experiment was Thomson, and he came up with a very basic model of the atom, and he called this the plum pudding model. Now, he assumed that the entire atom was positively charged, and then it had electrons kind of dotted around it, and we use the term plum pudding model, okay? And a better way of explaining it for nowadays, since we don't eat plum pudding, is the chocolate chip model. The chocolate chips are the electrons, the rest of the cookie is the positively charged sphere. Now, the next scientist was actually Rutherford, and he tried to prove Thomson's model, plum pudding model, correct. And so what he did was he sliced gold foil extremely thinly, and he shot alpha particles into the gold foil. Now, if Thomson's model was correct, Rutherford expected that most of the alpha particles would be deflected because we're assuming that most of the gold atom is positively charged. However, what he saw was that most of the alpha particles, which are positively charged particles, they actually passed just straight through the foil without being deflected. And then only a few were deflected, and those that were deflected were actually deflected at severe angles, way beyond what Thomson would have expected. And so Rutherford actually came up with a nuclear model in which he stated that most of the mass of an atom is actually found in a centralized place, which he called the nucleus. And in addition to this, he noted that most of the volume of the atom is actually empty space with electrons moving through. So he got rid of the plum pudding model, which stated that most of an atom was positively charged particles, and instead, actually, most of an atom is empty space with some electrons floating around, and most of the mass is very concentrated in the nucleus. So our modern view of the atomic structure involves protons, which were discovered by Rutherford, and neutrons, which were discovered by Chadwick, and those are found at the center in the nucleus, and then electrons are outside of there, and those were discovered by Thomson. And so this is the modern view of the atom. Now, because the atom is so small, rather than talking about the mass in terms of grams, we use the unit AMU, which stands for atomic mass unit. So 1 AMU actually equals 1.66 times 10 to the negative 24th grams. So it is a very, very small number. So when we're talking about atoms, their mass is actually very small. Now the next term we need to talk about, every atom of a specific element has the same number of protons. However, they can differ in their number of neutrons. So for example, C12, C13, and C14, all carbons have the same number of protons, which is 6. However, they can have a different number of neutrons, and those atoms are called isotopes of one another. So just a couple of review terms. The mass number is the number of protons plus the number of neutrons, and the atomic number is the number of protons. So the way that we write this, we write the chemical symbol for the element on the right-hand side, like carbon. We put the mass number up top, so for example 12, and then the atomic number on bottom. And so the number of protons would be 6, the number of neutrons would be 6, and the mass number would be 12. So what I'm going to do in this video is I'm going to show you how to determine the number of each subatomic particle for the nitride ion, because we've talked about protons, we've talked about neutrons, we've talked about mass number, but the one subatomic particle we haven't talked about that has a large role here is electrons. So for nitrogen, if you look at the periodic table, nitrogen has 7 protons. Okay, so I'm going to write it 7p plus here. Now, the next thing you have to determine is the number of electrons. Well, if nitrogen had no charge, it would have 7 electrons. However, because it has a 3- charge, that means that it has 10 electrons, because it has 3 electrons more than it has protons. If it had a positive charge, let's say it had a 3+ charge, for example, then it would have 7 protons but only 4 electrons. So notice we never change the number of protons, because that is what identifies what type of atom, what type of element we have. What we will change if we have an ion is the number of electrons. And then what you need to do for nitrogen, if you notice in the problem, it tells you that the mass number is 14. Well, if the mass number is 14, remember, protons plus neutrons equals the mass number, so the number of neutrons here would be 7. Okay, and that's how you do it. Now really quickly, if you look at the periodic table, you don't actually see mass numbers on the periodic table. Instead, you find atomic weight. And that's because we actually sum the weighted average of all of the different mass numbers. So for example, if you have 75.78% of chlorine 35 and 24.2% of chlorine 37, meaning 75% of the naturally occurring chlorine is chlorine 35 and 24% of the naturally occurring chlorine is chlorine 37, what you're going to do is take a weighted average. So to do that, what you do is you convert the 75% to a decimal, so 0.7578, and you multiply it by its atomic mass, which is 34.969. The 35 is just a rounded value. Then you're going to add to that the percent of chlorine 37, which is 24.22%, but make that into a decimal. So it would be 0.2422 times the atomic mass. And then you add those together, and that gives you your atomic weight.